There is a silence in the deep universe that is not simply the absence of sound, it is the absence of time. When you look up at the night sky, you are not looking at a static painting of the present, you are looking into a graveyard of the past. The light hitting your retina left its source years, centuries, or millennia ago. You are always, inevitably, looking back. But there is a limit to how far back we were supposed to see. For generations, humanity has operated under a comforting assumption that if we stared long enough into the deepest, darkest cracks of the cosmos, we would eventually see the beginning. We believed that if we built a machine powerful enough, an eye capable of collecting the faintest, dying whispers of the first light, we would witness the birth of the universe. We expected to see chaos. We expected to see the messy, violent nursery of existence, where gravity was just beginning to stitch together the first clumps of gas into the first fragile stars. We expected to see the dark ages of the cosmos, a time of quiet gestation before the lights truly turned on. We were wrong. We built the machine. We sent it 1,000,000 miles away from Earth, to a point of gravitational solitude known as Lagrange Point 2. We unfolded its golden, honeycomb eye, shielded it from the heat of the sun, and let it stare into the abyss for days on end. And the abyss stared back, not with the face of a newborn, but with the glare of a fully grown, terrifyingly ancient monster. This is the story of the James Webb Space Telescope, and the discovery that has sent a shiver down the spine of modern physics. It is not a story of triumph, it is a story of a locked door that we forced open, only to find that someone, or something, was already waiting for us on the other side. Picture a grain of sand held at arm's length against the black sky. That tiny speck covers a patch of darkness that appears empty to the naked eye, but focus a lens on that grain of sand for long enough, and the darkness dissolves into thousands of galaxies, each containing billions of stars. This is the deep field. It is our method of time travel. The deeper we look, the redder the light becomes, stretched out by the expansion of the universe over billions of years. Redshift is our clock. A low redshift means an object is close, a neighbor in cosmic terms. A high redshift means the object is ancient, fleeing away from us at the very edge of the observable universe. We built James Webb specifically to hunt for the highest redshifts, to find the first light. The Standard Model of Cosmology, the specific set of rules we use to describe how the universe works, gave us a very clear prediction of what that first light should look like. According to the math, the universe began 13.8 billion years ago. For the first few 100 million years, it was a hot soup of hydrogen and helium. Gravity is a weak force. It takes time to work. It takes eons to pull that gas together, to ignite fusion, to build a star, and then billions of years more to assemble those stars into the spiraling, organized majesty of a galaxy like our Milky Way. Therefore, the baby universe should look like a baby, small, messy, dim, disorganized. We expected to find pipsqueaks, irregular blobby proto-galaxies struggling to form. We expected to see the scaffolding of the universe, not the finished building. Then, the data came back. It arrived as a series of unassuming files, transmitted across the cold void to the Space Telescope Science Institute in Baltimore. At first, it looked like noise, faint reddish smudges on a black background, but as the astrophysicists cleaned the images, calibrated the spectra, and calculated the redshift, the silence in the control room grew heavy. The numbers were impossible. They found galaxies, not proto-galaxies, not clumps of gas. They found massive, bright, structured behemoths. They found galaxies that were as heavy as the Milky Way, shining with the intensity of 100 billion stars. But here is the horror. They were sitting at a point in time where they could not exist. These objects, designated by technical names like JWST Z140 or simply the Red Monsters, date back to just 300 to 500 million years after the Big Bang. In cosmic time, this is a blink of an eye. This is minutes after the birth. Imagine walking into a nursery ward, expecting to see newborn infants, and instead finding fully grown adults sitting in the cribs, staring at you with ancient eyes. That is the visceral shock that hit the astronomical community. According to everything we know about physics, there was simply not enough time for these galaxies to grow. To get that big, a galaxy needs to consume gas, merge with neighbors, and spin up over billions of years. Gravity cannot work that fast. It is physically impossible to assemble that much matter in such a short window. It is like finding a 100-year-old oak tree in a garden. That was planted yesterday. So, the panic set in, the papers began to fly. They called them universe breakers. At first, the scientists tried to bargain with the data. Maybe the calibration is wrong, they whispered. Maybe the telescope is too sensitive. They checked the mirrors. They checked the sensors. The machine was perfect. The light was real. Then they tried to bargain with the models. Maybe our timeline of the Big Bang is off, but to move the Big Bang would unravel a century of evidence. The cosmic microwave background, the abundance of light elements, the expansion rate, they all lock the age of the universe in place. The walls of our reality are set. These galaxies are inside the walls, but they are too big to fit. This leaves us with a terrifying set of possibilities, each more unsettling than the last. Possibility 1. We do not understand gravity. Perhaps in the early universe, gravity was not the patient, gentle sculptor we know today. Perhaps it was a voracious, crushing force that snapped matter together in an instant. If the fundamental laws of nature change over time, then we are standing on shifting sand. We cannot trust the ground beneath our feet. Possibility 2. These are not galaxies at all. This is where the cosmic horror begins to bleed into the science. Some astronomers, desperate to explain the brightness of these little red dots, have suggested that we are not looking at starlight. Stars fuse hydrogen into helium. It is a clean, understood process. But to produce this much light so early, you would need stars that defy the limits of mass, or you would need a monster. There is a theory that these objects are not filled with stars, but are powered by direct collapse black holes. In the modern universe, a black hole forms when a massive star dies. It is a tombstone. But in the early universe, the gas was so dense, so hot, and so abundant that perhaps it didn't bother making stars first. Perhaps the gas clouds collapsed directly into the singularity. Imagine a cloud of gas the size of a solar system crushing itself down into a point of infinite density in a single violent event. The energy released would be blinding. It would outshine an entire galaxy. It would look, to our telescopes, exactly like these impossible galaxies. If this is true, then the dawn of time was not a period of gentle creation, it was an era of monsters. It means the universe was born populated by supermassive black holes, ravenous, invisible mouths waiting in the dark before the first star even had a chance to ignite. It means that at the very center of our history, there is a rot, but there is a third possibility, one that is rarely spoken of in press releases because it touches on the philosophical dread that keeps astronomers awake at night. What if they are just there? What if the universe did not start from a simple point of low entropy? What if it was born ready-made? The implication of fully formed galaxies appearing instantly at the beginning of time suggests that our linear narrative of evolution is a lie. It suggests a universe that is cyclical, or perhaps a simulation that was booted up with the assets preloaded. The James Webb Telescope was meant to be a time machine. It was meant to take us back to the simple, comforting beginning. Instead, it has shown us that the further back we go, the more complex the picture becomes. We are like explorers who sailed to the edge of the map, expecting to find open ocean, and instead crashed into a wall of iron. And this is only the first anomaly. As the telescope continued its survey, peering into the unseen epochs, it found something else. Not just galaxies that were too big, but chemistry that was too rich. You see, the early universe should be clean, just hydrogen, helium, maybe a pinch of lithium. Heavy elements, carbon, oxygen, nitrogen, the stuff of life, are cooked inside stars. It takes generations of stars, living and dying, exploding and scattering their ashes, to pollute the universe with these heavy metals. Yet, in the spectra of these ancient, impossible galaxies, we found carbon, we found oxygen, we found dust. Do you understand the implication? To have that much dust and heavy metal 300 million years after the Big Bang is like finding a human skeleton in a dinosaur fossil. It shouldn't be there. It implies that millions of generations of stars lived and died in a blink of an eye, undetectable to us. Or, it implies that the ingredients of life are not a byproduct of later evolution, but were present from the very start. It suggests that the universe was habitable long before it was survivable. We are staring at a crime scene where the body is fresh, but the footprints belong to a ghost. The Standard Model of Cosmology, the Lambda CDM model, is currently held together with duct tape and hope. Every new image from Webb tugs at that tape, and we haven't even talked about the voids in between. These bright, impossible monsters, there are gaps. Great, spherical, empty spaces where the density of the universe drops to near zero. If the early universe was a thick soup, these bubbles shouldn't exist yet. They are too large. They imply a repulsive force, something pushing matter away with violence, clearing out pockets of space like a grand excavation. We are looking at a construction site, but we cannot see the builders. We only see the impossible structures they left behind. The data is currently sitting on servers around the world, being picked apart by algorithms and graduate students. They are desperate to find a boring answer. They want to find that it's just dust calibration. They want to find that active galactic nuclei are tricking us. They want the safety of the known, but the data is stubborn. The red monsters are there. They are watching us from the beginning of time, and their very existence questions the stability of our reality. We thought we were alone in the dark room of the universe, slowly turning up the dimmer switch. But James Webb just turned on the floodlights, and we realized the room is full of furniture we didn't buy, arranged in patterns we don't recognize. And the scary part? We have only looked at a fraction of the sky. To understand why this is terrifying, you have to understand the sheer absurdity of the speed involved. We need to step away from the abstract numbers of billions of years and bring this down to a human scale. Imagine you decide to build a house. You pour the concrete foundation at 8 Gaussian. In the Standard Model of Construction, you would expect the frame to go up by noon, the roof by evening, and the furniture to arrive next week. It is a linear, logical progression. Now, imagine you pour the concrete at 8 a.m. You blink, it is 8:01 a.m., and suddenly, a fully furnished 100-story skyscraper is standing in front of you. The lights are on, there is food in the fridge, the elevators are running. This is what James Webb saw. In astrophysics, there is a speed limit to growth. It is called the Eddington limit. This limit dictates how fast a black hole, or a galaxy, can consume matter. When a black hole eats gas, that gas heats up and glows. The radiation pressure from that glow pushes outward, fighting against gravity pulling inward. If a black hole tries to eat too fast, it chokes. The outward pressure blows the food away. It is a self-regulating mechanism. Nature has a choke point. The red monsters that Webb found are defying this limit. They are not just eating, they are gorging. They are growing at rates that shouldn't be physically possible without blowing themselves apart. This implies that the early universe was not a vacuum that slowly filled with matter. It was a pressure cooker, a place of violence so extreme that the laws of thermodynamics, the laws that keep our own sun from exploding, were temporarily suspended, and this leads us to the darker realization the universe might have been born old. If these massive structures were already in place so quickly, it suggests that the seeds they grew from were not random quantum fluctuations, as we were taught. It suggests the seeds were massive to begin with. This brings us to the concept of primordial black holes. Standard black holes are made from dead stars. They are the corpses of the universe. But a primordial black hole is different. It is a hypothetical nightmare object that formed in the first fraction of a second after the Big Bang, created not by death, but by the sheer crushing density of the universe itself. If Webb is seeing the light from accretion disks around these ancient monsters, it means the universe was born with cancer. It didn't start with light and life. It started with millions of invisible, gravitational traps waiting to consume everything that formed. Think about the implications of that. We usually view the universe as a vast, open frontier waiting to be explored. But if the cosmos was seeded with heavy black holes from the very start, then the universe is not a frontier, it is a minefield. We are navigating a dark room filled with open manholes, and we have only survived this long because we happen to be in a quiet corner of the room. But the horror of the Webb discoveries goes deeper than just black holes. It touches on the very fabric of space itself. It touches on a crisis known as the Hubble tension. This is the dirty secret of modern cosmology. We have two ways to measure how fast the universe is expanding. Method 1. We look at the baby picture of the universe, the cosmic microwave background, and we project forward to today. The math says the universe should be expanding at 67 kilometers per second per megaparsec. Method 2. We look at the local universe, pulsing stars called Cepheids, and exploding supernovae, and measure how fast they are moving away from us. The math says the universe is expanding at 73 kilometers per second per megaparsec. 67, and 73. These numbers do not match. They are not close enough to be a rounding error. They are statistically incompatible. For years, scientists hoped that our telescopes were just blurry. They hoped that once we got a better look, the numbers would agree. James Webb just took the sharpest look in human history. It measured the sea feeds with perfect clarity. It measured the background with perfect clarity, and it confirmed the discrepancy. The numbers are still wrong. This is not a whoops moment. This is a reality is tearing moment. It means that the ruler we use to measure the cosmos is broken. Or, far more terrifyingly, it means that the laws of physics are not constant. It suggests that the physics governing the early universe, the 67, and the physics governing our local neighborhood, the 73, are fundamentally different. The universe is acting like a fluid that is changing its viscosity as it flows. Why is this scary? Because if the laws of physics can change over time or over distance, then we are not safe. We rely on the constancy of constants. We rely on the fact that gravity works the same way here as it does a billion light years away. If that assumption breaks, then our ability to predict the future of the universe, or even the future of our own sun, evaporates. We are drifting on a raft, assuming the ocean is water, only to realize the liquid beneath us is slowly turning into acid. Let's go back to those impossible galaxies for a moment. There is a specific detail in the Webb images that keeps astronomers awake at night. It's the shape. According to the hierarchical model, early galaxies should be messy blobs. They are crashes, accidents, shapeless clouds. But Webb is finding disks, beautiful, flat, rotating disks. A disk requires order. A disk requires a calm, stable environment to settle down. You cannot build a house of cards in a hurricane. Yet, these galaxies built houses of cards in the middle of the cosmic hurricane that was the early universe. This suggests that there is an invisible scaffolding holding them together. Something we cannot see is imposing order on the chaos. We call it dark matter, but that is just a label we stick on our ignorance. We don't know what it is. We only know it is heavy, it is invisible, and it is everywhere. Webb is showing us that this invisible substance was organized and powerful almost immediately. It's as if the skeleton of the universe was built before the flesh was put on, and this skeleton is vast. It forms the cosmic web, a network of filaments that stretches across the entire observable universe. Galaxies are just the pearls strung along these invisible threads. When we look at simulations of this web, it looks strikingly uncomfortably familiar. It looks like the neurons in a human brain. This is the ultimate cosmic horror thought experiment, usually reserved for late-night philosophy, but now backed by data. If the universe has a structure that mimics a neural network, and if that structure formed instantly and efficiently, is it a system? Is the universe a biological entity? And if it is, are we the life within it, or are we the virus? The red monsters that Webb found, those bright early galaxies, are pumping out ultraviolet radiation so intense that it rionized the universe, clearing away the fog of neutral hydrogen. They literally altered the state of the cosmos. They cooked the universe. If we look at the timeline, it seems the universe was terraformed, or rather, cosmoformed, very quickly, very early, by these impossible machines. This brings us to the edge of the abyss. We have looked deep, and we have found that the history we wrote for ourselves is a fairy tale. The real history is faster, heavier, and more violent. But the worst part is not what we found, it is what we haven't found. With all these heavy elements, all these mature galaxies, all this carbon and oxygen present at the dawn of time, where is the life? If the ingredients were ready 13 billion years ago, why does it look like we are the only ones here? If the table was set for dinner at 8 a.m. and we didn't arrive until midnight, who ate the meal? The silence of the universe just got much louder, because now we know the conditions for noise were there all along. The fact that we hear nothing suggests that something stops life, something cleans the house. We call it the Great Filter, and Webb just hinted that the filter is behind us. Or it is waiting right in front of us. We are drifting towards a horizon we cannot see, propelled by a force we cannot touch. If the discoveries of the James Webb Space Telescope have taught us anything, it is that the universe is not a static stage. It is a machine in the middle of a violent runaway process. And we have arrived just in time to watch the lights go out. We spoke of the red monsters, those ancient, impossible galaxies sitting at the dawn of time. But there is a flip side to their existence. By measuring their light, and the light of the galaxies that followed, Webb has helped refine our understanding of the universe's trajectory, and the prognosis is terminal. The universe is expanding. We have known this for a century, but until recently, we assumed gravity would eventually win. We thought the collective mass of all those stars and black holes would act like a brake, slowing the expansion down, perhaps even pulling everything back together into a big crunch, a reset button for existence. But the data tells a different story. The expansion is not slowing down, it is speeding up. There is a mysterious pressure pushing the cosmos apart. We call it dark energy. It is the dominant force in the universe, making up nearly 70% of everything that exists, and it is relentless. The Hubble tension, that terrifying discrepancy in the numbers that Webb confirmed, suggests that this acceleration might be more aggressive than our standard models predicted. It implies that the space between galaxies is growing so fast that it is overcoming the speed of light. This leads us to the concept of the cosmic event horizon. Imagine a runner sprinting away from you. If they run faster than you can run, they will eventually disappear over the horizon. In cosmic terms, the galaxies are the runners, and light is our running speed. Because space itself is expanding, the distant galaxies are being carried away from us faster than their light can reach us. They are falling off the edge of the observable universe. Every second you have been listening to this, a portion of the universe has crossed that line. It has become causally disconnected from us. No signal, no spaceship, no light will ever reach it again. It is deleted from our reality. The James Webb Telescope is a time machine, yes, but it is also a catalog of things we are losing. When we look at those deep field images, we are looking at ghosts. Many of the galaxies in those pictures have already crossed the horizon. They are gone. We are seeing their lingering reflection, like a thunderclap hearing the lightning strike long after the storm has moved on. In the far future, billions of years from now, this acceleration will reach a fever pitch. The galaxies outside our local group will drift away into the black. The night sky will go dark. Future astronomers, if any exist, will look up and see nothing but our own stars. They will have no way of knowing that a vast, rich universe ever existed. They will think the Milky Way is the entirety of creation. They will be alone in a way we can barely comprehend. But we don't have to wait billions of years for the horror to set in. The horror is here, in the implication of those early galaxies. Let's return to the most disturbing realization of all. The universe was ready for life 13 billion years ago. The Webb data showed us carbon, oxygen, and complex structures just moments after the Big Bang. This means the Goldilocks zone for life spans almost the entire history of the universe. So, where are the others? If the universe is a fertile garden, and it has been fertile for 13 billion years, we should be tripping over ruins. We should see Dyson spheres blocking the light of stars. We should hear the radio chatter of a trillion civilizations. Instead, we have the Great Silence. There are two ways to interpret this silence in light of the new data. Interpretation D, we are the first. This is the optimistic view, though it is terrifying in its own right. It means that despite the ingredients being there, life is impossibly rare. It means the red monsters were sterile. It means we are the first consciousness to wake up in 13.8 billion years of darkness. The responsibility is infinite. If we die, the universe goes blind again. We are the only thing that gives the cosmos meaning. Interpretation B, we are the last. This is the view that chills the blood. It suggests that life did arise early. It suggests that civilizations did build empires among those ancient, bright galaxies, but something kills them. Maybe civilizations are like those early, massive stars. They burn bright and die young. Maybe intelligence is a self-correcting anomaly. Maybe the technology required to signal across the stars is the same technology that inevitably destroys the species that invents it. If the universe was habitable 13 billion years ago, then billions of civilizations could have risen and fallen before our sun was even born. We are walking through a graveyard, wondering why nobody is greeting us. The silence is not empty space. It is the quiet of a mass grave. And James Webb, by showing us how alive the early universe looked, has made that graveyard exponentially larger. There is one final thought to leave you with, a thought that questions the safety of the very ground we stand on. We mentioned that the laws of physics might have been different in the early universe to allow for such rapid growth. There is a theory in physics called vacuum decay. It suggests that the energy state of our universe, the vacuum we live in, is not the lowest possible state. We are resting on a ledge halfway down a cliff. We call this a false vacuum. If the laws of physics are evolving, or if they were different in the past, it implies a volatility. It implies that the ledge is slippery. If a bubble of true vacuum, a lower energy state, were to form anywhere in the universe, it would expand at the speed of light. It would rewrite the laws of physics as it passed. Chemistry would fail. Atoms would unbind. Gravity would change. It would be a wall of deletion, rushing toward us at the speed of light. We would never see it coming. One moment, we are here, pondering the stars. The next, the laws that hold our atoms together simply cease to apply. The anomalies Webb is finding, the tension in the expansion rate, the impossible mass of early galaxies, could be the tremors warning us that the ledge is not stable. We are trying to measure the stability of a bridge while we are standing in the middle of it, hearing the bolts groan. So, did James Webb look too deep? In a sense, yes. We wanted to find our origins. We wanted a family photo album. Instead, we found a crime scene. We found a universe that plays by rules we don't understand, operating on scales that render us invisible, with a history that is deeper and darker than we dared to imagine. We built a golden eye to see the face of God, and we found a mask. And now, we are left to wonder what lies behind it. The telescope is still out there, 1,000,000 miles from Earth. It's back to the sun, facing the freezing void. It is collecting data right now. Every day, it downloads more terror. Every day, it chips away at the illusion that we are significant or safe or understood. But we cannot look away. The human instinct is to stare into the abyss, even as it pulls us in. So, tonight, when you close your eyes, remember the red monsters, remember the silence, and remember that we are drifting on a small raft in a dark ocean and the tide is going out. Good night.